This is the John Hancock Tower, the tallest building in New England. It won one of America's top architecture honors, just 2 years after engineers warned it could fail in a major storm. $160 million. The insurance company that built it sealed every mistake behind a decade of legal agreements. How does a 60-story skyscraper shed over 100 500-pound glass panels onto public sidewalks, and the people responsible say nothing? The tower was designed to honor a 19th century church next door. So why did construction crack its stone walls, shatter its stained glass, and nearly collapse its foundation before the building was even out of the ground? Wind tunnel testing confirmed the structure could fail in a storm. So why were 1,500 tons of emergency steel added to a completed occupied building without a single public announcement? And how does a building with plywood where its windows should be walk away with the highest honor in American architecture?
The stone people objected to that. They say, we've never done it this way because if we do it, it will be broken.
The John Hancock Tower made sense on paper. In the late 1960s, John Hancock Mutual Life Insurance, one of the largest insurance companies in the country, wanted a headquarters in Boston's Back Bay. They hired I.M. Pei and Partners, one of the most prestigious architecture firms in the world. The design fell to Henry Cobb, a senior partner, and one of the most respected skyscraper architects in America. A razor-edged rhomboid tower, 60 stories of reflective glass, rising 790 feet above Copley Square. No ornament, no visible structure. Just a sheer blue mirror beside Trinity Church, an Episcopal landmark built in 1877 and designated a National Historic Landmark in 1970. The church was not just old, it was the building that defined an entire style of American architecture. Cobb's answer was to make the tower disappear around it, not compete, reflect. In a 2003 interview, "It's a silent building. The reason it's silent is it's designed to respond to Copley Square. 2 million square feet of office space, the tallest structure in New England. A $75 million budget backed by a company that had spent a century pricing other people's risk." One detail did not make it into the press releases. The permit had been denied for over a year. Boston's architecture community opposed the project. Residents opposed it. After 9 months of hearings, approval came not because opposition softened, but because John Hancock threatened to move its entire operation to Chicago. 12,000 jobs gone. Construction began in August 1968. That was the plan. Here's what actually happened. 10,344 panels, each measured 4 feet by 11 feet and weighed 500 pounds. The panels were bonded to the metal frame using a rigid solder. That solder is where the system failed. Glass moves. Think of it like a car tire bolted directly to the axle with no suspension. Every bump transfers straight into the frame. The rigid solder worked the same way. Instead of absorbing stress, it transferred every load back into the glass. Each Boston winter loaded the panels further. The fractures were invisible until conditions pushed them past the breaking point. By January 1973, the failure was impossible to ignore. A winter storm hit with gusts reaching 75 miles per hour at the upper floors. In a single night, at least 65 panels fell, some shattering midair, others landing on Copley Square sidewalks as intact 500-pound sheets. More than 100 panels failed across the early 1970s. Boston police closed surrounding streets whenever winds approached 45 miles per hour. The city erected an enclosed walkway around the building's base so pedestrians could pass without walking under open sky. An office tower in one of Boston's most prestigious neighborhoods had become a falling object hazard zone. Nobody walking below could know when the next panel would go. More than an acre of the facade was covered in painted plywood blue boards, replacing panel after panel visible from across the skyline. The sleek mirror had become a checkerboard. Bostonians called it the Plywood Palace. In October 1973, IM Pei and Partners announced that all 10,344 panels would be replaced entirely at John Hancock's expense. The new glass, single-pane, heat-treated, tempered. The original had been rated for 35 to 40 pounds per square foot, roughly the force of a moderate highway crosswind. The new panels came in rated for 220, 6 times stronger. Spotters watching for failing panels were paid $4.05 an hour. No one on the street below knew they were there, and the glass was only the beginning. The foundation damaged everything. Boston's Back Bay is not natural land. In the mid-1800s, the city filled in tidal mudflats with gravel and sand. The resulting soil is soft, saturated, and unpredictable under load. The Hancock Tower did not account for it well enough. During excavation in 1968, roughly 500 million pounds of earth were removed. The retaining walls warped inward under pressure. The ground moved and did not stop at the construction fence. That movement rippled outward through the neighborhood. Utility lines buckled, sidewalks cracked. Across Clarendon Street, Trinity Church, the 1877 landmark the tower was designed to honor, began to break apart. Stone masonry split along mortar joints. Stained glass windows dating to the 1870s shifted in their frames. 6 murals painted by John Lafarge Irreplaceable Works, commissioned specifically for Trinity in the 1870s, were damaged. Engineers had to pump groundwater from the Hancock excavation pit beneath Trinity just to keep the church's wooden foundation pilings from cracking. Trinity Church filed suit in 1975, arguing that Hancock's negligent construction had damaged a National Historic Landmark. A Suffolk Superior Court jury awarded approximately $4.17 million. With interest, the total exceeded $11 million. The Massachusetts Supreme Judicial Court upheld the verdict, a rare and very public loss for one of the largest financial institutions in America at the hands of a 19th century church. But the excavation damage turned out to be a warm-up act. Then it gets worse. Workers on the upper floors noticed it first. In high winds, the building moved. Not a subtle vibration, a sustained sway enough to shift objects on desks, enough to cause motion sickness, 60 stories above Copley Square. Engineers tested a scale model in MIT's Wright Brothers wind tunnel. The sway was real. The solution, a tuned mass damper. William Lemessurier, a structural engineer based in Cambridge, Massachusetts, oversaw the installation of 2 steel boxes on the 58th floor, each 17 feet square, filled with lead. Each weighed 300 tons. Combined 600 tons on lubricated plates connected to the frame with springs and shock absorbers. When the tower leaned, the weights pulled it back. Cost $3 million. The people on those floors felt the sway stop. Nobody told them why. But the wind tunnel had found something else a problem the damper could not fix. The original engineering had left the tower's narrow faces critically underbraced. Under specific wind conditions, the building faced a theoretical risk of catastrophic structural failure. A 60-story occupied office tower in the middle of Boston. The engineers who studied it most closely were not certain it could survive every storm the city might produce. Their answer, 1,500 tons of steel bracing inside the frame. Structural surgery on a completed operational building. No public announcement. Those working inside weren't notified. Drilling went on for months around them. No one explained why. The building needed lifeguards. And this is the part no one wants to answer. The original budget was $75 million. By the time the tower opened on September 29, 1976, 5 years behind schedule, the total cost had exceeded $150 million, and by some accounts reached $160 million, more than double the original estimate. The reglazing $5 to $7 million, structural reinforcements $8 million, Trinity Church damages $11 million, carrying costs on a building the owner could not occupy. Hancock executives had over $100 million tied up in a structure they couldn't use, watching it shed windows onto the street while paying lawyers to keep the technical findings sealed. The replacement glass introduced a new problem. The original dual-pane units had provided thermal insulation. Single-pane tempered glass does not. Every winter and summer after 1973, the building carried heating and cooling costs. It was never designed to carry a financial penalty, compounding for decades. Nobody who approved this project lost a dollar of their own money, but the record of how it happened was about to disappear too. In 1975, John Hancock filed suit against IM Pei and Partners, the New York architecture firm, and 5 other firms. The case settled out of court in 1981. The terms were not disclosed. The non-disclosure agreements extended into the legal resolution. The full record of why the building failed was suppressed for over a decade. When the engineering firm hired to investigate finally published their findings at an American Society of Civil Engineers conference in 2000, nearly 30 years after the panels started falling, their conclusion was unambiguous. The fracture was rooted in the design of the insulating glass units. The truth, as they put it, had been lost in legal protectionism. Even after reglazing, the tower employed full-time spotters with binoculars and polarized lenses, scanning the glass daily for panels showing signs of darkening. When flagged crews replaced them before they could fall, the full truth stayed sealed for nearly 30 years, and all of it traces back to one decision. In 1977, the American Institute of Architects gave the John Hancock Tower its National Honor Award, the top prize in American architecture.
John Hancock building under construction, and what an extraordinary event it was in the city.
To the AIA panel, the building achieved something specific, a modern corporate tower that could stand in one of America's most historic neighborhoods without overwhelming it. Clean geometry, reflective glass that deferred to Trinity Church rather than competing with it. Whether the building worked for the people living and working around it was not part of the evaluation. By those criteria, it was a success. But the award had no category for falling glass, no criteria for emergency steel, no measure for sealed settlements. The architects and the engineers were evaluating the same building. They were not seeing the same structure. A 60-story tower, $160 million. Engineers weren't certain it could stand. The 600 tons of lead are still moving on the 58th floor. The 1,500 tons of bracing are still bolted inside the frame, invisible to every tenant, essential to the building's survival. The spotters are gone, but the fixes, never announced publicly, are the only reason the building is still standing. In 2015, the building's owner dropped the John Hancock name entirely. The company that built it had moved out. The lease expired. The tower that John Hancock Mutual Life Insurance built to project permanence is now called 200 Clarendon Street. Some engineers and historians argue differently. The Hancock Tower became a landmark case study that rewrote testing standards for glass curtain walls, tuned mass dampers, and skyscraper wind loads. The failures pushed the profession forward in ways that have protected thousands of buildings since. The architects saw a building with clean proportions and a compelling relationship to its site, and the AIA agreed. Both of those things can be true at the same time. But the people whose windows broke, whose streets were closed, whose historic church cracked at the foundation, none of them were asked. And nobody who made this decision is being asked to justify it today. In 1978, structural engineer William Le Mesurier discovered that the Citicorp Center in New York, a 59-story tower he had also designed, had a critical flaw in its bracing joints. Under quartering winds at a 45-degree angle, Le Mesurier calculated a 1 in 16 annual chance of collapse. He disclosed the flaw-coordinated emergency repairs at night, while the building stayed open, and arranged an evacuation plan covering a 10-block radius. Repairs completed by end of 1978, not made public until 1995. The same engineer, a different outcome, the same silence. Name a glass tower in your city built before 1985. You don't know what's holding it together. The project you just watched took years to fail publicly. The next one on this channel took longer and cost more. Subscribe, because by the time it makes the news, it's already too late. Comments are open. Name your city.